Up until now, we've been solving differential equations where we could separate the variables. In other words, we could get all the x's and the dx's on one side and the y's and the dy's on the other. But now at this point, we're talking about equations where we can't exactly do that. They're not separable. So there is a way to solve these if they're homogeneous. And so this video is going to talk about how to determine if a differential equation is homogeneous or not. All right, so what we do is we replace the x with tx and we replace the y with ty. If we can then factor out all the t's and not leave any inside, then it is in fact homogeneous. So let's start with this first example. So I'm going to replace x with tx and the y with ty. All right, and now I can just expand this, t cubed x cubed minus 4 t, and then this would be a t squared, so that becomes t cubed. This would be an x and a y squared. This would be a t cubed y cubed. Okay, and now notice that I can factor out of each one of these the t cubed term. Okay, I'm going to factor out my t's, so I get t cubed. And I'm left with x cubed minus 4x y squared plus y cubed. Notice that I pulled out all the t's. They're out front, so this is in fact homogeneous. Let's do an example where it's not, and you'll see the difference. Over here, I'm going to start the same way. Replace my x with tx, so that's tx cubed. Over here, tx squared. My y goes to ty, so that's ty squared, and this y goes to ty squared. Expanding this out, I would have t cubed x cubed plus 3. Now this is t squared and a t squared, so that's going to be t to the 4th. X squared, y squared, and here I'm going to have minus 2 t squared, y squared. Notice now when I factor out my t, the largest t I can factor out is a t squared, put that out front, but here I'm left with tx cubed, and here I'm left with 3t squared y squared. I did factor this one out, minus 2y squared. But since I'm left with t's in the parentheses, I can't factor those out, this is in fact not homogeneous. And now, when something is homogeneous, we can actually solve the equation. So the way that we solve a homogeneous equation, differential equation, is by replacing y with vx, and then this just follows. If we take the derivative of vx, it would be the first thing times the derivative of the second plus the second thing times the derivative of the first. So we're going to replace dy with that. So the first thing I'm going to do is rewrite my y prime as dy dx. You can spend your time trying to separate this, but take my word for it, it's not. Okay, so now what we're going to do here is go ahead and put my dx over there. Okay, so let's just do dy, because we know that y prime is dy dx. Is going to be equal to x, and now in place of y, I'm going to have vx. In the denominator, I've got my x squared. In place of y, I'm going to have vx squared. All right, and now for my dy on this side, it becomes v dx plus x dv, and now that's going to be equal to, I can go ahead and multiply this out, x squared v over x squared minus x squared v. Okay, and I'm sorry I forgot the dx here. All right, and now notice on the right hand side my x squares all cancel, so I'm left with v dx plus x dv equal to v over 1 minus, and this was actually a v squared, because when I square this, the v's get squared, dx gets squared. Okay. And now I'm to the point where I can replace my v with, my y with vx. Okay, remember we made that substitution at the beginning. Okay, so I'm going to replace v. If I solve this back out, v is going, if y equals vx, then v equals y over x. So I'm going to substitute for v y over x. So this would become y over x, and this would become y over x squared. Okay, now because this is in the denominator, it kind of flips around, and this term right here will become minus x squared, all right, over 2y squared, and that is going to be equal to the natural log. Notice here my x's would cancel out. This I've replaced with y over x. Natural log of cy. Okay, and now I just want to get rid of the natural log. I can e both sides. Okay. Over here I'm left with e to the minus x squared 2y squared. Over here these cancel out. So to get what y is, I would divide each side by c. But remember, c is just a constant. So that's just going to end up being multiplied by c. So my final answer is going to be y equals c e to the minus x squared over 2y squared. Again, I e'd both sides. The e and the natural log canceled out and just left me a cy. So I would divide both sides by c to get rid of the c. But remember, c is just a constant, so I don't have to worry about it. I can just put the constant here, okay? Because it could end up being 1/2. It doesn't need to stay in the denominator. So this is my final answer. All right, so that's how we use the homogeneous to solve. Basically, we do the substitution, y with vx, and then dy with v dx plus x dv.